All right, folks, welcome once again. Okay, so welcome to day 2, right? We are in day 2 of our 15 day course, and we are still in module 1. Remember, we need 3 hours, right? We need 3 hours, so 1.5 sessions is what we need for each module. So today we're going to do we'll finish module 1, and in the second hour today we'll start module 2. Okay. Now this is where we are, right? This is our course structure. So we'll be finishing up module 1 today, and then starting module 2 as well. So today's topic for the whole session today, we'll mostly be talking about EC2 instances, right, or EC2 as a service. And you can say that the goal today will be to essentially launch an EC2 instance and be able to connect to the instance, right? So after today's session, you should be able to do that yourself, okay? And that's why I hope you have created your free tier account already, okay? Because you will need that to practice how to launch the EC2 instances and how to connect to them, okay? And also, we'll be doing lots of demonstrations from today onwards, and there'll be lots of things to practice, okay? So it's very important that you have your free tier account set up. All right, so let's get going. So this is all right, so this is the objectives that we spoke about yesterday for the objectives of module 1, right? And mainly yesterday we looked at the global infrastructure, right? Remember, we spoke about regions, availability zones, and edge locations, right? So that's very important to understand. And we also spoke a bit about the benefits of this infrastructure, and also a bit about how to pick a region, because you have to pick one region, right? And most people pick one region and have all their stacks in that one region, right? And some people also have a second region, which can be your secondary site or your disaster recovery site, right? But no matter what you do, it's very important to pick one region based on factors such as cost, network latency, legal considerations, right? So that's very important. So we've done that already. So today, we'll start talking about EC2 instances. So we'll talk about the EC2 service, and then the EC2 instance. All right, and we'll also talk about various instance types. There's a whole range, a very large range of instance classes and instance types and sizes as well. So we'll talk a bit about that. And finally, we'll close this module by talking about the purchasing options. Okay, that's because with cloud computing, you have pay-as-you-go pricing, right? And EC2 instances will normally form a very big part of your organization's bill. AWS therefore offers a number of ways in which you can control the cost, you can optimize the cost, right? So it's very important to discuss the purchasing options. All right. Okay. So let's get started. We'll now be talking about EC2 instances and the EC2 service. All right. By the way, we'll use the same sheet. I think one of you also sent me a message saying that you didn't have the link to the sheet, right? So let me share that once again. And what we'll also do is we'll use the second sheet today. Okay, even though we've not started module 2, given that we're talking about EC2 instances, it's better that we use the second sheet for our Q&A. All right, this just to organize the questions properly. Okay, so here's the link. All right, I'm sending the link to this document once again to everybody. I know I saw an email from somebody asking for this email. I hope you're online and you're able to get this link today. All right. Okay, and Sudhakar, yes. So I hope you've got the link. So what you should do is you should bookmark this, right? Because we'll be using this link and this document throughout this course, and also after the course, right? You might want to refer to this material even after the course. All right. Okay. All right, so let's get started. Okay, so EC2, right? Let's get started with EC2. So EC2 is the name of the service, right? It's the name of the service, and it's basically Elastic Cloud Compute. Okay, that's the full form. And Elastic. Why do we say Elastic? We say Elastic because it's it's kind of stretchable, right? You can think of it as a rubber band, right? You can stretch it to whatever extent you want, and you can also it also works in the other direction, where if you release the rubber band, right, it comes back to its smaller shape. Okay, so that's the way to think of cloud computing in general. In that you can if you want larger servers, you can get that easily. If you want more servers, you can get that as well, right? And also in the other direction, if you want something smaller or if you want fewer servers, it's possible to do all these things, right? So that's why we say elastic. Okay, and cloud compute. So compute usually refers to servers, right? So that's why Elastic Cloud Compute is basically server technology, right? These are basically virtual machines, okay? VMs, virtual machines. And this is something that most of you should be familiar with, right? You must have used VMs already in your projects, right? In your companies. Even if you've not used cloud computing, you must have used virtual machines already, right? So in that sense, EC2 is not a great leap in terms of technology, right? It's the same thing. It's the same thing that has always been there, or well, rather not always, but has been there for a long while with us. Okay, so that's why EC2 is something that you should learn first because it's easy. Okay, it's easy to get going with EC2. It's the same as the VMs that we've been using. All right. Now, what is an EC2 instance? So an instance is one server, right? So EC2 is the service, and you can have many instances, right? And an instance is one server. So you may have a Linux instance, say a Red Hat instance, right? And or you may have a Windows instance, right? And so basically it's one server, and you can have as many servers as you like. All right. Okay. So this is the first thing. Now let's talk about the various instance types. All right, so let's talk about different types of instances that are available in EC2. So there are, as you can see, there are many categories here. So general purpose, and then compute optimized, memory optimized, storage optimized, and GPU. Right. So there are 5 different types of instances available. These are broad categories, right? And within each category, you have different sizes and also some subtypes as well, right? So there are many. It's a very big range of servers that is available, right? You can pick whatever you want, and also if you don't like it, you can also always change. Okay, so in the cloud, it's very simple to change from one type of server to another type of server. Okay, so also you should note that before the cloud, right, outside of cloud, these things are very difficult. Okay, so if you buy a server, it's very hard to change that, right? If you change your mind, you can't change the server, but in the cloud, it's possible. Okay, so let's just review this quickly, the various categories of servers, and then the various sizes of servers within that as well. Okay, so first is general purpose, right? And you should always start with general purpose. No need to worry too much about compute optimized, storage optimized, and the other servers, right? Start with general purpose because these servers will be fine for most of your needs. Okay, everybody should start with general purpose. Don't worry too much about these classifications, these categories, right? Just start with general purpose. Okay, now within general purpose, you can see there are a few columns here: T2, M4, M3, and so on, right? So these are different types of servers. Okay, they have different performance characteristics. Okay, for example, the T type is the one that has what is called burstable CPU. Okay, burstable CPU. So what this means is, there are some use cases where most of the time the CPU utilization is at a certain level, let's say, right, and then suddenly there could be bursts, right? So the demand goes up very suddenly, and then it vanishes as suddenly as well, right? So it's a very spiky kind of traffic, let us say. Okay, so for those kinds of use cases, the type of instance is better. All right, and the M type is more for stabler types of workloads. All right, so there are different kind of subtypes that are available. And the number that you see after this, right, T2 or M4, that's basically a generation, right? So before T2 there was T1, before M4 there was M3, right? So it's basically generations of technology, and if you're creating a new server, try and use the latest server. All right, so that's what these things mean, and otherwise you can see, some of the, some information about the characteristics, like, what is the processor that is used, what's the kind of CPU available, what's the kind of memory available, right? But I think, these things are, I mean, you don't have to be too concerned about the micro details of each server type, right? So if you need to, right? If you need to, you can go into these things at some point, but at this point, don't worry so much, right? Just be aware that there's a T type which is for burstable, spiky loads, right? M4 for more stable loads. That's all, right? Nothing too complicated here. Okay, all right. Now within general purpose, you have various sizes of servers, right? So this is more important, I would say. So you have, say, something like Nano, which is a very small server, right? So this has one virtual CPU and half a gig of RAM, right? This is the memory, not the disk, right? It's not the disk we're talking about. We're talking about the memory. That's about half GB. So half a GB is a very small server. For example, this laptop that I'm using today probably has, I'm not sure, maybe 4 GB or 8 GB of RAM, right? And this server, you can tell, is a very, very small server, right? And then you have a micro, which is larger. By the way, micro server is the one that's covered under the free tier, right? You should always use micro when you're practicing. Okay, so this way you'll have lower cost. Okay, so and then there's small, medium, large, and so on, and you have some servers which are extremely large. So 10x large, for example, has 40 virtual CPUs and 160 GB of RAM, right? So you have the full range available. You can pick whatever suits your need. Okay, all right. Now the other thing that you should note is the cost, right? So you with EC2 you normally pay by the instance hour. Right, so every hour of usage, right? And when we say usage, what we mean is if the server is up, okay? If the server is running, that means the server is being used, and you will be billed. All right. So you may not use the server at all. You may not have any users. Okay, that doesn't matter. All right. As long as your server is running, you'll be billed. All right, and you're billed by the hour. And there is no partial hour. Okay, so if you use a server for 5 minutes, you'll still be billed for 1 hour. All right, and so you build on an hourly basis, and this is, by the way, one of the costs, right? So when you run a server, this is not the only cost. There could be other costs as well. For example, on the storage side, which we'll talk about when we look at EBS, there could be some networking cost as well, the amount of data that goes in and out of the server, right? So those kinds of costs are there as well. But the main cost of EC2 instances, and also the main cost of your in your bill is going to be because of these instance hours. All right, and you can see the cost. The cost actually is, for a micro server, for example, is very small. You can see it's 1 cent per hour approximately, right? 1 cent per hour. That's very, very cheap, and the cost goes up linearly with the size of the server, right? Almost linearly. So the bigger the server that you have, the more the cost. All right, but these are extremely low costs, as you can hopefully gather from this pricing. Okay, so this is Linux pricing. Now Windows servers may be slightly more expensive because you have to pay for the software cost, right? So Linux is open source, there's no software cost, but Windows is not, so you may have to pay a slightly additional, a higher hourly cost for Windows servers. All right. Okay. So this is I think the main thing. You have general purpose servers, and then you have various sizes. You can pick what you like, and remember, you can change, right? If you don't have to plan too much. Okay. In the cloud, there's no need for planning too much. No need for too much of analysis, right? Just pick what you think is going to work. If it doesn't work, just change it. All right, so you can easily go from micro to small, small to medium, and so on. It's no problem. All right, now the other types, right? So now let's say the other categories. So that there's compute optimized. This is, don't worry so much about it. Basically, compute optimized instances are those that are sort of tuned. They are optimized for compute type of workloads where compute is more important. Okay, and the simplest way to think of this is to think of compute optimized as servers which will give you more compute per dollar. All right, more compute per dollar. That's the simplest way to think of compute optimized instances. Okay, and you can see there are some, there's a range of sizes available here as well. You don't have the smaller size. You don't have the nanos and micros, right? The minimum is large, and then you can go up to 8x large. So the range is slightly less here. All right, but otherwise it's something similar, right? It's the same as general purpose in that sense. You can look at some use cases as well on this slide. So SharePoint, Microsoft SharePoint, Portal, or SAP, right? The ERP. So those kinds of applications are being run on compute optimized instances. Okay, so this is from information from AWS, I guess. So AWS knows what its customers are doing. So what they find is people are running SAP and SharePoint on compute optimized instances. All right, storage optimized is basically more storage or better storage per dollar. Okay, same thing. It's optimized for storage needs, and when it comes to storage, we're basically talking about EBS, Elastic Block Store, which we will talk about in module 3. We will spend some time on EBS there, but at this time what you need to know is there are usually, there are two types of storage that is available with EC2 instances. One is SSD. These are solid state devices, right? And the other is HDD, the traditional hard disks, right? And SSDs are more expensive, and they're faster. Okay, they're faster, so they're good for, say, large databases, Oracle or NoSQL databases, MongoDB, right? So they're good for those kinds of things. And HDD is better for throughput sensitive applications, say Hadoop. Okay, so SSD is good for databases, traditional databases, NoSQL databases, and HDD is better for throughput type of applications, stuff like Hadoop. Okay, so that's the main difference you should know about when it comes to storage. All right, and in terms of use cases, you can see Hadoop is a use case, and then warehouses, right? Data warehouses. So this is where in both these cases, data warehouses, these are traditional enterprise data warehouses, and Hadoop, which is big data, which is a hot topic nowadays, and both of these are applications where the size of data is extremely large. Right, so data warehouses, enterprise data warehouses can have lots of data because data accumulates over time, and the warehouses have data from multiple applications stored in a single place, right? So the amount of data is very large. And Hadoop, of course, Hadoop is basically for semi-structured, unstructured type of data, and those kinds of data, for example, log files, right? Web server log files, those can be very, very large as well. Right, so you can see the use cases for storage optimized instances are things like warehouses and Hadoop. All right. Next, we have memory optimized, right? So again, the same thing, more memory per dollar, and the use cases here are for example, Spark and Presto, right? So these are tools in the big data ecosystem, right? And these are tools which are doing lots of things in the memory, right? So maybe they are pulling up a lot of data from the databases, and they are doing in-memory calculations, aggregations, analysis, right? So they need a lot of memory. So for these kinds of applications, memory optimized instances might be better. All right, and finally you have GPU. These are more for graphical type of processing, 3D applications, maybe video games, video encoding, and so on. Machine learning as well. I understand that GPU instances are better. Okay, so broadly, these are the various categories, right? But again, don't worry so much, right? It's not so important to look at these categories and the various sizes, right? Go with general purpose. Go with something small, right? That's all you need to worry about. Go with micro, because that's what is covered under the free tier, right? Later, if you think it's not working out well, you can always change. All right, and that's why we say here on this slide, we're saying instance resizing, right? So it's simple, just a few clicks, right? Just 1 or 2 clicks is what you need to go from one server type to another server type, right? So there's no need for too much of analysis. Don't worry so much about it. Just go with something that feels okay. All right. Okay. So now let's talk about the last topic in this module, right? And here we're going to talk about the purchasing options. Okay. So this is these are on-demand, reserved, and spot. So there are 3 ways in which you can buy EC2 instances. All right, and you know, it's not just EC2 instances. For example, some of these options are also available with other types of resources, RDS instances, for example. Okay, so but the broad idea is you have an on-demand way of buying instances, right? And here, what happens is you may need a server, right? And you don't foresee yourself using the server for a very long time, right? So it's a short-term use case, let's say, right? So maybe you want to do a proof of concept. You want to deploy some application on an environment, or maybe a test environment or a proof of concept environment, and show it to some people, show it to your business teams, right? And then once the proof of concept is done, you don't want the servers, right? You want to give away the servers so that you're not build anymore, right? Or maybe you want to set up a test environment. The testing will go on for 2 weeks, not more, right? So these kinds of use cases are there, right, all the time, and for that, on-demand instances are best. Okay, so when you want to launch servers, and then you want to have the flexibility of terminating those servers at short notice, right? You will use on-demand instances. All right. So this is the most expensive option. Okay, this is the most expensive option that is available. The other option that's very important is reserved instances. All right. By the way, you know, when we say on-demand instances, when we say reserved instances, we're not talking about servers, right? These are purchasing options. These are ways of buying these servers, right? So reserved instances or reserved purchasing option is basically when is used for use cases where you foresee using a set of servers or one server for a longish period, right? So this could be, say, at least 1 year. Maybe you see, you know, maybe you have an application which is stable, right? It has stable usage. Right, you don't see you not using that application, right? So that infrastructure is going to be there. That's what you can estimate, right? So you need the server for the foreseeable future, 1 year, 2 years, 3 years, right? And therefore there you can then buy a reserved instance, right? And what it means for you is that a reserved instance is like a bulk discount, right? So you're committing, you're saying, yes, I'm going to use the server or servers for 1 year at least, right, or longer, 2 years at least, right? So you're making a commitment to using the server, right, and therefore paying for it. Okay. By the way, you have to pay for it. Once you reserve an instance, you have to pay, right, even if you don't use it. All right. So it's a commitment to pay for a longer period, 1 year, 2 years, 3 years, right? And in return for that commitment, you get a kind of a bulk discount. All right, so that's why reserved instances can be much cheaper. They can be 50% cheaper, 60% cheaper. All right, so that's about the range. So it can be about 60% cheaper than on-demand instances, right? So naturally, you can imagine, right? 60% is a very big amount, and your business side will be very happy with that. Okay, so you need to think about, you know, when do we use reserved instances, right? Also, you have to be careful because it's a firm commitment. Right? You can't back out. You can't say later, no, sorry, I made a mistake, right? I don't want a reserved instance. You can't do that, right? So it's a firm commitment. You need to think about it, but you know, as long as you plan properly, reserved instances will be a very important part of your cost optimization strategy. All right. The last option is called spot instances. Okay, so these are, you know, not, I would say, not as important as reserved instances. Okay, normally we use on-demand instances, so that's you know, that's the default option. You have to use on-demand instances. Reserved instances are very important to reduce the cost, right? Spot instances is an interesting topic. Okay, but they're probably not used as much. All right, so they have a, the use cases are narrower, right? They're not used as much, and the reason is that spot instances are basically available on an auction basis, right? And these are instances which are it's basically idle capacity, right? So AWS has very large data centers. A lot of that capacity that they have, server, storage, etc., is not used often, right? So their thinking is, look, we have idle capacity, right? We're not making any money on it anyways, right? So why not just offer it on an auction basis? Maybe we'll make some money out of it, right? So even if it is a very small amount, at least it's better than nothing, right? So that's the whole idea. So they offer idle capacity on an auction basis, right? And then depending on the demand and supply, the price of the servers can change, right, dynamically. Okay, so the price of the servers is changing all the time, and you can bid. You can bid, like you do in an auction. So you can bid for server capacity, and if your bid is higher than the actual price, you get the servers. All right, and because it's an auction mechanism, and depending on the situation on the ground, depending on the demand and supply, basically, right, and the demand and supply varies based on server size, the region that you're using. Sometimes it varies by availability zone as well, right? So the whole system is very dynamic, right? And in Singapore, you may not have servers, but you may find lots of capacity in some other region at a very low price, right? So all these things are very dynamic, but assuming that your bid price is higher than the actual price, you will get servers, right? And if the conditions are right, if the competition is less, right, you're the only one, let's say, who needs servers, right? Maybe you need 100 servers. There's not much competition. Then you'll get these servers for a very low price, right? Just above zero. Just above zero. So that's why spot instances can be extremely cheap. They can be 90% cheaper than on-demand instances, for example. Okay, so spot instances can be very cheap. However, there's a catch, right? And the catch is that if the actual price, the actual price is changing all the time, remember, right? Depending on the demand and supply. So if if the actual price goes beyond your bid price, right? Which means you're not competitive anymore, right? Your bid is not competitive anymore. So then the servers will be taken away from you, right? Abruptly. Okay, so the servers go away suddenly, right? And therefore the use cases are narrower. So basically you will use them first of all for situations where for you cost is a very important consideration, right? So for example, a university doing some genome calculation, right, or some NASA doing some the NASA, the space agency, the US space agency, they might be doing some calculations, very massive calculations using some space photographs, right? So let's say you need thousands and thousands of servers, right? And when you're talking about that kind of scale, cost becomes very important, right? And therefore you tend to look at spot instances for these kinds of use cases. All right, and also the applications have to be designed in such a way that they can handle interruption. Right. Remember, I said that if the actual price goes above the bid price, the servers can be taken away. Right. So your jobs can be interrupted, and therefore your applications have to be written in such a way that they can handle interruptions. All right. Okay. So these are the three purchasing options that are available. Normally, you'll use on-demand instances, right, for short-term use cases. Then you'll use reserved instances often because it's very important, right, to bring down the cost. And this is a great option. And it can be used for, say, live environments which are more stable, right, which you will use for the foreseeable future, right. And then spot instances have a narrower use case set. You can especially use them for batch programs, but you have to make sure that your applications can handle interruptions. All right. Okay, folks. So that's it. That's all that I wanted to cover in module 1. Okay. Let's do a little bit of Q&A. Let's do a little bit of Q&A on what we've just talked about, right? So basically EC2 instances, the instance types that we saw, and then the purchasing options, right? So let's just understand this well, because remember, EC2 is something that you're going to be using all the time, right? It's a core service. You have to use EC2 instances. Okay, so once we do this, we'll then move on to module 2, where we will start looking at the implementation of EC2, right? So we'll see how to launch EC2 instances, we'll see how to connect to them, and then tomorrow we'll also see how to install software, deploy applications, and we'll also try and create an application on EC2 instances and make them work end to end, right? From DNS to IP address, and we'll see the application working end to end. So that's coming up tomorrow, but today we'll see how to at least launch and maybe connect to the EC2 instances. All right. Okay. So let me just look at these questions here. So Uday, how AWS will calculate the bill and how we can verify where the usage data will be stored internally in AWS. Yeah. So the billing is done automatically, right? So billing is done automatically. Okay, and you get a very granular itemized type of bills, right? So there's no need to worry, right? Everything is very transparent, okay, and once you start using this, your concern will go away. Okay, it's a very pricing is very transparent, billing is very transparent, it's very accurate. There's no need to worry about this. Okay, but let me show this to you. How this works. So let me log into my account. All right. I hope you have created your accounts, like I said before, and if you log in, you'll see something like this page here. So let me just enter my second factor. You may not see this page, by the way. This is a two-factor authentication which I have enabled. We will see how to enable this for your accounts in some other module. All right. But once you've logged in, you'll see a home page like this, right? This is the AWS Web Console. All right, and if you look at your billing dashboard, right? So from the top right menu, you can go into your billing dashboard. All right, and there you'll find your bill, right? So you can find the bill for this month, the current month, and also for previous months, right? So for example, this is my bill here, and if you look at the bill section, you can look at the bills for any month, right? So let's say we're looking at this month, right? And you can see it's very detailed, right? So $20 is the bill, and you can see the biggest amount is this one, right? Elastic Cloud Compute, and within this you can see full details, right? So how is the cost calculated? So most of the cost is coming from this line item, right? This is a micro instance, a Linux micro instance running in Singapore region, right? And we've used 720 hours so far. All right. Some of the cost is coming from EBS, which is a storage that is used with this instance, right? And you can see, the pricing, the rate, right, and the usage. 6 GB months are being used here, right, and so on and so on. Okay, so it's very, very detailed, very granular, very transparent. Don't worry so much about it. Okay, the other thing is also that the bill is up to date, right? So anytime you look at the bill, it's up to date, which means like in your mobile phone, right? Your telecom provider doesn't give you the bill until the end of the month, right? So suddenly you get a bill, and then you can and then sometimes there's bill shock, right? So in the telecom industry, there's a term called bill shock, where let's say you've gone to some other country, right? There's a roaming charge which can be very, very high, right? So those kind of things can happen because you see the bill only at the end of the month, which may be very different, very much later than the time at which the usage happened, right? But here the bill is up to date. Okay, so the bill is up to date. You can see it any moment. There are also ways in which you can set up budgets, and you can get notifications if the actual cost goes above the budget, and so on, right? So it's much better and much more transparent. All right. Okay. What's the Chandra? Next question. Chandra. What's the difference between EBS and SSD? No. So that's not how it is, right? So EBS is a service, is an AWS service, right? And SSD, solid state devices. This is a type of EBS volume. right? A volume is like a hard disk. Okay, so the hard disk volume, I mean, it's like a hard disk. It's not really a hard disk, but the volume, the EBS volume, can be of type SSD or it can be of type HDD. Okay, so there's no comparison. EBS and SSD are not to be compared. All right, EBS is a service, SSD is a type of volume within that service. Right, the comparison is SSD versus HDD. Okay, this is fine. This is a comparison that you can do, all right, but not EBS versus SSD. All right, James, can you change your instance and number of CPUs and other details after paying to have it converted to a reserved instance? If so, how do the cost changes work? Yeah, so no, so in general, right? In general, once you reserve an instance, right? Once you reserve an instance, you are locked into it. Okay, you can't change too much. All right, but now there is some flexibility. Okay, there is some flexibility now, but the main thing to understand is that you better be sure about what you are doing. All right, so you don't have too much flexibility. You should assume that you can't get out of it once you reserve that instance. Okay, and you have to not just specify the instance type, right? Normally you reserve, when you reserve, right? When you reserve, you have to specify the instance type. You know, for example, let's say you want T2 small, right? Let's say this one. Then the region, okay. Then also I think the availability zone, also the platform, whether it's Linux or Windows, right? And in general, once reserved, you can't change any of these. All right, okay, so this is something you should understand. However, in the recent past, now or in recently, there have been they're trying to give you some additional flexibility, right? So recently there are some options to liquidate, right? So basically you're stuck with this asset and you're looking to liquidate. So what you can do is you can sell this instance in the AWS marketplace, right? Now you need a buyer, right? Assuming you get a buyer, you can sell this in the marketplace. That's one option. Okay. The other option is you have some options to change. So you may be able to change. You can change to say small. The T2 small can be changed to say 2 T2 micros. Okay, micros. But this will be in the same region, maybe in the same AZ, right? So all these things, I'm not 100% sure of. I don't remember the details. You can look that up, but there is some flexibility in changing from one type to another, right? Not too much, some flexibility, and of course you can also sell it in the marketplace if you find a buyer. All right, but those are options to that'll come later, right? But the first thing you have to understand is be very careful, right? Be very careful. In general, you're locked into it once you reserve the instance. All right, sure. Okay, next question, Uday. Who's taking care of purchasing instance in real time? Is it our task? Is any approvals required? What is the procedure we follow in the real environment? Yeah. So remember, yesterday I also told you that the cost optimization, right? The cost management of your infrastructure now lies with the technology people more, right? Before cloud, you could, your procurement department or your finance department would handle the maybe the vendor negotiations, right? They would handle the payment, right? And most of the payment used to be upfront, right? But now here, you can see, right? You're beginning to see that the decisions you make on an ongoing basis will have an impact on the cost, right? And often the decisions will have to be taken by technology people, right? And those decisions will not be clear to the procurement team or the finance team, right? So that's why cost optimization and the management of the cost becomes a part of your responsibility, right? So Okay, so that's a big change. So in the cloud, cost optimization is the responsibility of the tech folk, right? This could be, say, exactly who that you guys can decide within your organization, but it's with technology now, right? Because it's an ongoing process. All right, now who's taking care of purchasing? You are, right? Whoever the decision maker is, right? So the tech people have to sort of decide what to buy, right? And whether to reserve or not, whether to use Spot or not. That's somebody in your team, right? Somebody in your team. Maybe it's you. Maybe it's a project manager, right? Maybe you can have some process where someone makes a proposal, someone does an approval, right? So you can set that up. That's up to you. All right, that's up to you. So I think you can, set up some kind of process for these things, right? Maybe something simple with the proposal approval type of process can be done. All right. By the way, this is an important topic, because in my experience, I've seen, there is tension between the business side of the company and the tech folk, right? Because usually technology people are not too concerned about cost, right? It doesn't matter to them, so they tend to be, liberal, right? They tend to use whatever resources they like, and they don't prioritize cost optimization, right? So there can be tension between the business side and technology people. So you may need a process, right? So that the business side knows what's going on. Right, they have some idea at least of what's going on and what you're doing to sort of control the costs. Okay, so this is something, an important thing. So tension, let's say, right, between business and tech on the cost front, right? So keep this in mind when you sort of set up this kind of process. All right, next question, Shashi. When we need to change the server type, case one, do we have to worry about the installed software, or does it automatically replicate the things when we go to the different type? And the second case is, can we hold the same IP address which associated with the other external resource? Yeah. So yeah, you can change instance type, say from T2 micro to, say, T2 small, right, with a click of a button. All right, there is some outage, right? It's not like this, the server is up. The server does go down briefly, okay, but no need to reinstall software, redeploy application, nothing of that sort, right? The whole thing is as if nothing happened, right? You just come up again on a bigger server, and this whole application, the whole software is just the same, right? So no need to do anything else. It works very smoothly. Okay, the IP address is a more complicated topic. Okay, we'll discuss that more. But the IP address can be the same. The public IP address of your server. The public IP address, and this is, it's something called elastic IP that we use. Okay, we'll talk about this in module 2. Can be sort of transferred as well. Okay, so it's not a problem. The change can be very, very smooth, right? At the end of the day, what you want is the change to be smooth, no impact, nothing complicated, right? And that's how it is. Okay, can we get billing alerts? Of course you can, right? So you can say something like, if actual is more than, say, 50% of budget, right? Let me know. Okay, so these kinds of things can be done, no problem. All right, Renju, is it possible to change the instance type? Or adding more CPU or memory to it after provisioning the instance? No, so no way to add CPU or RAM. Okay, you have to change the instance type for that. Okay, so there's no way to only add one type of resource, right? You have to change the instance type for more or less resources, right? So if you need something more, something or something less, you have to change the instance type. There's no way to only change CPU or. Okay, Babita, in spot instances, if they are once allocated, how can they be given for bid again? Yeah. So they can't be reserved. Okay, so the spot instances cannot be reserved. They're not on demand, right? So what happens is it's a auction, right? It's an ongoing auction, right? It's an ongoing auction. So say at 10 a.m. 10 a.m. Your bid, you bid say $1, right, per hour for a say 10x, let's say say 4x large server. Okay, so at that time the actual price is let's say half a dollar, right? This is based on the demand and supply at that time, right? So you get the server, uh, uh, right, at 10 a.m. All right, because your bid is the highest bid, and you get the server. Now remember, you're not billed at the bid price. You billed at the actual price, right? So your billing happens at the actual price, not the bid price. So why I'm telling you this is, you can bid high. Okay, you can bid high so that you're sure to get the server, right? But actual bill will be much lower than your bid price. Okay, so this is how you get the server. However, let's say at 11 a.m. There is competition. There are other people in the same region, AZ, right, who are looking for that kind of capacity, who are looking for 4x large, right, 4x large servers. So then their bid is, let's say their bid is say $1.1, which is higher than yours. Okay, so you may lose those servers, right, or some of those servers. Depends on lots of factors. Depends on how many servers they want, depends on how many servers you've got, right? So you may lose some of those servers because their bid is higher, right? So it's like this. It's a dynamic auction. So what you can do to retain the servers, right? So the strategy, there are many strategies for spot bidding. Okay, so what you can do is to retain spot instances. The strategy is bid high, right? Bid high. So nobody else will compete, and then you're sure to retain the capacity, right? And now remember, you're not billed on the bid price. You're billed on the actual price, which may be far lower than your bid price. All right. So Nagar, is the instance cost, does it include the operating system, or does it have a separate cost? It does. It does include the software cost, right? For example, Windows. All right, Windows. So the cost will be included, right? But remember, the server can have any software, right? It can have say Oracle, right? Or it can have say IBM WebSphere, right? So it's not just the OS, right? You can have servers with other kinds of software going up the stack as well, right? You can have third-party software, third-party commercial products as well. Okay, so the software cost the instance cost will include the software cost, depending on what software exactly is available on that server. Okay, so the hourly cost includes both hardware and software cost. Okay, Valen, any other possibility to stop my instance from reaching $100 bill automatically? You can, what's your use case, right? What is the use case? Because let's say you're running a production application, right? You're not going to stop your production application if your bill reaches $100, right? So what's the use case? Let's understand that. Then maybe we can see what the solution is, right? So you can write some scripts. You can write a script which looks at your bill and then stops your instance. You can do all those things, but I don't think that's the right way, right? The right way is you should have a good idea about what you're doing, right? You should have some budgets, you should have some notifications set up, right? And as long as you are disciplined, you understand what's going on, these are not a concern, right? These are not a concern, right? So I don't think you should think of these kinds of solutions. It's better to handle it in different ways. Okay, next question, the last question, I think here, Babita, if the bidding, what's the point of bidding? No, okay. So I think what you're saying is if the billing is at the actual price, then what's the point of bidding, right? So that's what I guess what you're saying. No, it's a normal auction process. Normal auction process where well, yeah, well, okay. So I guess in a normal auction, you pay the bid price. Okay, so maybe that's what you're thinking, right? So in a normal auction, let us say you are in an antique auction or some paintings auction, that kind of thing, right? In a normal auction, you pay the bid price, right? That's what you're thinking. But here it's different. Okay, here it's different. So here you pay the actual price at that point. Okay, so and the actual price at any point depends on supply and demand. Okay, supply and demand. Yeah. Okay. So that's what you mean. Okay. So if you bid high, nobody can get the server. Yeah, but then you run the risk of so bid high strategy. Let's say you have, right. So bid high strategy. What's the downside, right? That's what you're asking. So the downside is that you may end up paying, right? You may end up paying very high. You may end up with a big bill, okay? Because although you're billed on the actual price may approach your bid price, right? So actual price may approach your bid price, okay? So you might end up paying a very large amount, right? Because if your bid was lower, if the actual price hit your bid price or went above your bid price, you will lose the server. So you're not billed, okay? So there is a downside. There is a downside of bidding high, which is that the actual price may actually approach a bid price. All right. Okay. You can read more about this, right? So I think we've had a good discussion. It'll take a bit of time for all this to be for you to digest all this, right? But once you sort of start using it, once you start experimenting with all this, these things will become clearer and clearer. All right, folks. So, okay. So I think that's it, right? This was module 1, and what I suggest you do maybe, if not right away after the session today, right, is you can try these quiz. So there's one on infrastructure, the regions, availability zones, and so on. There's one on the AWS services, for example, EC2, S3, RDS, right? So it's important that you start reading up about the various AWS services, okay? And then maybe try this quiz to see test your understanding, right? Also, you should do this quiz on free tier. You should read up on free tier and then do this quiz just to make sure that you understand free tier well, all right? And we also now covered EC2 basics, stuff like reserved instances, instance types, and so on. So these are 4 items that you can try maybe after the session today. Okay. All right. Now one more thing is that I'm going to give you some assignments. Right. We'll talk about this more, but you have to do a little bit of reading, right? And what you should do is when it comes to AWS services, right? What you should do is just go to the AWS website, the homepage. Right, and if you just go to this products option here, right, you can see the various AWS services, right, under these categories like compute and storage and so on. So you have EC2 here, you have say Lambda, you have S3, you have EBS, right, you have RDS, the databases. So for any service, right, just click on that service, and you'll find the home page, right? This is a good intro page, and then you should read the product details page, right? This is a very important sort of information, right? So product details is very important. A lot of information available. You should go through this. Right? Try and go through this. Try and understand this to whatever extent you can. All right. Next, you should look at the pricing. Try and understand the pricing as well. That's very important. Okay. And then finally, look at FAQs, frequently asked questions, right? And frequently asked questions are normally, a little more advanced, right? So once you've sort of understood the product a bit, maybe once you've done some practice as well, right? That's when you can go through the FAQs, and these are very good resources, right? FAQs is a very good resource for understanding that particular service. Okay, so this is how you should proceed. In general, what you should do is, let's say tomorrow we're doing EC2, right? So you should before we do EC2, you should have sort of looked up the product details, looked up the pricing, looked up the FAQs, right? Next, we'll do storage. So you should have read about S3. You should have read about EBS, right? Before we do module 3, right? So that's how you should prepare for the upcoming sessions. All right. Okay. Okay. So now let's maybe we can take a break. Okay. Let's take a break. We can have a 5-minute break. So 5 minutes, and let's come back. Let's come back by all right. So it's 9:26. So maybe 9:31, 9:32, something like that. That's 5 minutes from now. All right. All right. So see you soon. See you soon. And then once we come back, we'll start with module 2. All right, folks. So let's begin. I hope you are back. All right. So let's start with module number 2. Okay, so this module is about EC2, right? It's about EC2, Elastic Cloud Compute, which we have, already introduced, right? And here the focus is on the practical aspects, right? The implementation of the EC2 instances, and also how to connect, how do we launch, how do we set up applications, right? So that's that sort of thing. So at the end of this module, right? At the end of this module, you should be able to launch your instances, set up your applications, right? Maybe create some proof of concept environments, maybe create some test environments, right? So that kind of thing we should be able to do at the end of this module, which we will finish tomorrow. All right. Okay. So here's where we are. Here's where we are, and like I said, we finish this tomorrow, and we should be able to sort of set up applications on EC2 instances at the end. All right. All right. Let's go ahead with module 2. Okay. So the objective is to get going, right? Is to see something, is to see an application, and we'll use WordPress. Okay, WordPress is a popular website software, right? Also called content management software. It's good for blogs. It's good for websites, right? So it's an open source thing. Anybody can use the software. It's free of cost. So we'll set up a WordPress site, and we'll see it working end to end. All right, so we'll set up WordPress on an EC2 instance and see it working end to end. And you should practice that, right? So once we finish the session tomorrow, you should be able to do the same. Install WordPress on Linux, maybe on Windows if you like that, right? And then make sure that you can use it, right? So that'll be the goal of this module, right? And but before to get there, we need to learn a few things, right? We need to learn a few things about EC2 instances. So we'll have to understand the Amazon machine image, right? So machine image, it's also called AMI. All right, the pronunciation is AMI, and the full form is Amazon machine image. Okay, so this is basically like a VM image. All right, and the image is essentially a template which defines what software will be installed on the instance or the server that you're trying to launch, right? So when you launch an instance, the first thing you specify is the AMI, right? For example, you may say Ubuntu, right? You want an Ubuntu OS on your server, or you may say I want a Windows 2012 on my server, right? So that's what an AMI does. It defines what software will be on the server. All right, so this is something we need to understand. Okay, we also need to understand security groups. These are basically firewalls. All right, firewalls, and each instance must have a firewall, right? It's a mandatory thing, and also we'll talk about security on the cloud, right? It's very important. On the cloud, remember, it's a public cloud, right? And you may have public IP addresses on your instances, which means anybody anywhere in the world can potentially connect to your server, right? So so in the cloud, security is extremely important. You have to take it seriously, right? Lots of people think, I'm just a startup maybe, or this is a simple application, nobody's going to be worried about my servers, right? But that's not right. Okay, it's only a matter of time before you get attacked. I know this from experience. All right, so you have to take security very seriously, and one of the things that you can do is to basically set up your security groups properly, right? So these are firewalls, and you need to make sure that your rules that you set up in the firewalls are sound. Okay, so that we will discuss. Okay, we will also discuss key pairs. Key pairs. These are public and private key pairs. Right? It's a pair of keys. One is public and one is private, and we use these to connect to our EC2 instance, especially on Linux. Okay, especially when we use Linux instances, but also you can use them when you use Windows instances as well, right? So this is another security feature of EC2 instances, right? And we'll take a look at this. Okay, we'll talk a bit about tenancy, right? So you can have shared versus dedicated. You have two options, shared tenancy versus dedicated. So dedicated is more for folks who want to have a private cloud-like environment, right? Where let's say that there's some regulatory reason why they don't want to have sharing, right? Basically, your instances run on hardware, on physical server, physical hosts, which are not shared with anybody else. Right? So that's what a dedicated instance is. And normally shared is fine. Right? Normally shared is fine. It's a virtualized environment. Right? You can have an instance on a physical machine, and in other customers, other people may have their servers on that same machine. That's fine. Right? That's fine. But sometimes, for some types of companies, some types of industries, dedicated instances might be important. Okay, it's a minor topic. Okay, the main things are armies, security groups, and key pairs. Okay, we'll also talk about this is important as well, right? We'll talk about elastic IP addresses, public IP addresses. There's also something called private IP addresses. Okay, so IP addressing. Basically, the topic is IP addressing, and there are different types of IP addresses available for each instance, and you need to understand, or we need to understand, what are the differences between these and which one to use when, right? So, because IP addresses are required when your users will need to connect to your applications, right? They may also be required when servers need to communicate with each other, right? So it's very important to understand IP addressing, because without IP addresses, you can't really communicate with these servers. Okay, so these are some of the topics that we will have to understand very well before we can deploy an application on the instance and start using that application. All right, so the goal is to get an application going, but we need to get these topics covered. All right, so what I'm going to do in this module is I'm going to explain this a bit, right? Explain this a bit, a few slides, and then I'm going to show you, right? So this is going to be lots of demonstrations from this module onwards, okay? And then as usual, we'll stop at appropriate times and do our discussion. All right, so let's get started. Okay, so let's start with armies, right? Amazon machine image. So so what is it, right? What is it? It's basically the same as a VM image, right? VMware image, let's say. So it's a kind of a template, right? I would say it's a template. It's not a server. Some people confuse an army with a server, right? It's not a server. It's just a template, and the template would say something like, what software will be on the server, especially the operating system, right? So you may say, I want an Ubuntu army, I want a Red Hat army, I want a Windows army, right? So that's something that you can do. Sometimes, the army can contain more than the operating system as well, right? So you may pick an Oracle army, for example, right? So Oracle running on Oracle database engine or software running on, say, Red Hat, right? You might want to pick something like that. So that's also possible. Okay, so the army can have any software, right? The whole stack, right? The whole stack, all the way up to the application, or the minimum stack, which can be an operating system that you like. Okay, so that's what an army is. It's a template for the software that goes into your server. All right. Okay. Now the army, you can. The army can be of different types. So some armies are defined or created by Amazon, by AWS, right? Some are created by the community. There could be some people who just want to create armies. Maybe they have some way of monetizing that, right? Maybe say open source communities will create armies because they want their software to be used more widely, right? So there are freely available armies created by various kinds of people, which are available, right? And then there's a AWS marketplace, and this is where you may have vendors, right? So these are independent software vendors. Let's say people like IBM, people like Oracle, Microsoft, right? And then the thousands of other software vendors that we have in the world, right? These could be end user applications. These could be application servers. These could be database technologies. These could be big data technologies, right? So all the the various software vendors that are out there in the world will also be interested in creating armies, right? Because they want to sell their software. Okay, so the army is a basic part of EC2, right? It's something that you must have to launch an instance, right? And you have a very wide selection, right, of open source software, of commercial software, and also, of course, you can create your own armies. By the way, right? You'll be doing that a lot. You'll eventually, you'll basically, initially start with say a basic server, say a Windows server or a Red Hat server. Then you'll install software, you deploy your application on that server, and then out of that server you can create your own army. All right. So once you create your own army, you can then use that army to launch hundreds of other servers with the same software, right? So yeah, okay. So army is a very important concept, and you have to sort of understand it properly, right? And be prepared to create your own armies eventually, right? Okay. We'll see this. I'm going to show this to you. Okay, so here's an example. Let's say you want to set up Hadoop, right? Let's say you want to set up Hadoop, which is a big data, platform, right? And so you have a few choices. One is you can maybe launch say an Ubuntu instance, right? And then manually install Hadoop on top of that, right? You can do that, or you can choose a Hadoop army, right? Which has Hadoop baked into the army. Right, so there are multiple ways of doing these things. You can choose a Hadoop army, right, and then once the server comes up, you have Hadoop up and running on that instance. Right, so those kinds of things you can do. Now, in the second use case on this slide, you can see there's some third-party products like Blue Data, SyncSort. Right, these are presumably big data applications or products, right? Commercial products from these vendors, and you'll find armies for these products in the marketplace as well, right? So you can pick those as well. So you can have a cluster of servers running Hadoop, and then another set of servers for these commercial products which will work with your Hadoop platform, right? So that's how the army process works. Okay, these are, this is a simple listing of the AWS marketplace for third-party products, right? Now, I'm not very familiar with most of these, but I think Trend Micro is a big company, right? This is basically sort of a security product, right? Oracle, of course, you're all familiar with, right? It's the premier enterprise database technology, right? So that's available as an army. You can simply select the Oracle army, right? The server comes up in a few seconds, right? And you have Oracle running on top of that server, right? Simply start using Oracle. Okay, so these kinds of things you can do with an army. All right, so let's see this, right? I'm going to show this to you. I'm going to combine some slides and some demonstrations, right? So that you have a good sense of what these topics are. Okay, so this is the home page, right? This is the home page, and you can see the various categories of services that we spoke about yesterday: compute, storage, databases, right? Management tools, and many others, like security, analytics, etc. Okay. Now we are interested in EC2, which is the first service under compute, right? And rightfully so. This is what you'll be using a lot, right? So let me click on this link here. Okay, so when you click on EC2, you come to the EC2 dashboard, right? So you come to the EC2 dashboard, and this is, by the way, you can see here, this is the Singapore region, right? This is the Singapore region. This is a production-like server, so I'm not going to use Singapore for this demonstration. I'm going to use this one, US East, right? So US East, this is North Virginia, right, in the US. And I like to use this for demonstration purposes, for training purposes, because I don't want to mix up my servers with my production servers running in Singapore. Okay, so this is one good idea that you can use. You can use one region for production, and you can use some other region for, say, test purposes or experimentation purposes. Okay, that's one way of looking at regions. Okay, the other reason I like to use North Virginia is because this is the region This is actually the first region I think that came about. And normally when there's a new product launch, or if there are new features that are rolled out, they're first rolled out in US East normally. All right, and then once they're tested, they are rolled out slowly to other regions. Okay, so when you're learning AWS, it's better if you use US East. Okay. Also, I think the cost in general is lower in this region because this region is very large, right? It has probably the biggest scale among all the regions. All right. So this is the US East North Virginia region. Okay, and this is the homepage, the dashboard of the EC2 service. There's a lot to digest here, right? For example, you can see here the instances. You can see stuff like spot requests, reserved instances, right? You can see the images, armies, essentially. This is EBS. We'll talk about this later. And then also there's load balancers, auto scaling. All these things are coming up later, right? So don't worry so much about everything that's here. We'll start simple. We'll just go step by step. Okay. So what I'm going to do is launch an instance, right? What we want to do is launch one instance, right? And the first step there is going to be selection of an army. Okay, so we'll do that. Now, before that, let me also show you the availability zones, right? So remember, yesterday we spoke about regions, and within a region, we said there's at least 2 availability zones, right? So every region will have at least 2. Now, this one has 5. It's a big one, right? It's a big region. It has 5 availability zones: A, B, C, D, and E. All right, so this is something interesting, and what we want to do normally for our production environments, live environments, is to have servers in multiple zones, right? At least 2. Okay, so if you have web servers, you have 2 web servers, set them up in 2 zones, right? If you have 4 web servers, you can have them in 4 zones if you like. That's good, right? Or maybe 2 into 2 each in 2 zones, right? So all those things you can decide. In general, the more servers you have, the better, and the more zones you have, the better. Right? Okay, now let's try and launch an instance. Okay, I'm going to click on this button, launch. And the first step is to pick, there's multiple steps here, right? So the first step is to pick the Amazon machine image. All right, now in the quick start tab, you can see there's some options available. Naturally, the Amazon Linux, this is a custom Linux version, managed, maintained by Amazon, right? This gives you some advantages, like it has a command line interface pre-installed. Okay, so it has some tools which are pre-installed. You might find this useful. Okay, but then also you may get logged in, right? So this is something that can lock you into Amazon. So you should go with whatever you normally use, right? So you may have a policy in your company. Maybe it's Red Hat that you like to use. Maybe it's Ubuntu that you like to use, right? Or maybe it's Windows, right? So maybe it's Windows that you like to use. Whatever it is, you can pick the army that you like. Okay, so but you'll notice these are operating systems, right? These are operating systems. Now you'll have to once the server comes up, you'll have to install some software on top of the operating system, deploy your application, and go that way, right? Or what you can do instead of choosing the operating system is you can actually go and search for something other than operating systems, right? So let's say if you go to the marketplace, right, and let's say you're looking for say WebSphere, right? Let's say you're looking for WebSphere, the application server, right? So you find the armies from these vendors. IBM is a vendor in this case, right? And you can also look at the pricing. By the way, the pricing is 36 cents, right? 36 cents per hour. So this includes the software cost and the infrastructure cost. All right. So you can pick this if you like. You can also pick others. For example, let's say you want to set up a PHP site, right? And for PHP, you need MySQL, you need PHP, you need Apache web server, right? And instead of installing all those things on an OS, you can simply say, give me a LAMP stack, right? A LAMP stack, Linux, Apache, MySQL, PHP. So there's somebody who has prepared this software, this army, right? And you can pick this. And what will happen is when the server comes up, all the software will be pre-installed for you, right? Because it's part of the army. Okay, so it's part of the army, so you don't have to go and install this software. You just have to look at how to deploy your application. All right, so So, I hope you're getting a sense of what an army is, right? It can be the operating system that's in the army, or it can be the whole stack, right? So yeah, think about that. All right, think about armies and how you want to use armies for your organization. Okay. Also, one more thing is you can create your own armies. This is extremely important, right? Eventually, you'll be creating your own armies. Okay, because let's say you have an application, you're not going to, you may need to set up servers with your application on it, right? And you're not going to install your application all the time. Right? Every time you launch a server, you don't want to install your application, right? So instead, what you'll do is you'll launch one instance, let's say Ubuntu, right? Install your application, deploy your application, and once it is successfully done, once you've tested it, right, you'll create an army out of that server, out of that one server, right? And then next time you need a server with your application, you'll simply use your army. You don't have to repeat the installation process. Okay, so once you have an army, you can launch hundreds of servers, right, with that one army. Okay, so it's, from productivity point of view as well, it makes a lot of sense. Okay, so now let's pick one, right? I'm going to use Ubuntu. So I'm more familiar with Linux and Ubuntu, so I'm going to use Ubuntu here for my demonstrations, right? You can easily, translate that the same sort of demonstrations to any other operating system as well. Okay, so for now, let's start with Ubuntu. I'm also going to show you later how to launch and connect to a Windows server. Okay, now I'm not very familiar with Windows, so I'm going to show you how to launch and connect to it, but that's about it. Okay, later when we install WordPress, I'm going to use an Ubuntu instance once again. All right, so let's pick this. Right, let's pick Ubuntu here. All right, so that's step one. Now, step two is your instance type, right? Your instance type. And remember, we spoke about general purpose. We spoke about compute optimized, right? We spoke about other types like GPU, memory optimized, and so on. And we also looked at the various types of servers. So, nano, micro, right? Remember, micro is free tier eligible. This is the only type which is free tier eligible, right? So you should always pick this. Don't forget, okay? So when it comes to cost management, right, you have to be disciplined. Discipline is the most important thing, right? So don't forget to use a micro instance when learning AWS. All right, so let me select micro instance here. You can choose anything, right? You can choose anything. You can also change later to any of these instance types. All right, okay. Now we have done step two. Step three. Okay, step three is stuff like networking and IP addressing, right? Let's leave this at the default values. Okay, let's not do anything here. We'll talk about all this later. Okay, we don't have to learn everything right away. Let's leave something, some of these things for later. So I'm not going to touch this, right? Leave this at the default value. Just a quick point: tenancy. Okay, tenancy. So this is where, if you like, you can choose one of the dedicated options, right? So here, let's say you're a bank. Your regulator demands that you run your applications on dedicated hardware, right? You can pick this. Okay, this will be more expensive because you're not sharing the hardware. All right, so this can be more expensive, but if you need to, you can pick that. All right, but otherwise, leave this alone. Don't do anything here, right? Let's move on. We'll come back to this page at some other time. All right. Okay. Now, next is storage. Okay. Next is storage. So this is EBS. Okay. This is an EBS volume. We'll talk about this in module 3 in detail. But at this point, what you need to know is the EBS volume is like a hard disk. Okay. It's like a hard disk. It's actually not a hard disk. Okay. It's more of a network-based storage. So there's EC2 instance, right? It goes over a network to a network-based storage. That's what EBS is, but it acts like a hard disk. Okay, in terms of behavior, it's exactly like a hard disk. Okay, so you have to, you can sort of have more volumes if you like. You can have more volumes if you like, right? You can have RAID configurations, where you have multiple volumes configured together to work together, right? So EBS volumes are very much, in terms of behavior, very much like hard disks. Okay, but But let's leave this here, right? We'll talk about this. We'll look at this in detail later. All right. Just at this point, what you need to know is that one EBS volume. This is the root volume, which means the operating system will be installed on this, right? You can also see that it has a size of 8 GB. Okay, it's an 8 GB volume. You can increase this if you like up to a maximum of 16 terabytes. All right, let's leave this. Tags we'll talk about later. And now we talk about security group. Okay, this is important. Security group. This is basically the firewall. All right, let me just explain this a bit on the slides here. Then we'll come back to this page. Okay, so security group is basically a firewall, right? It's a firewall, and each instance must have a firewall, must have a security group. Okay, but multiple instances can have the same firewall. Okay, so let's say you have web servers. You have, say, 10 web servers, right? All those web servers will have the same firewall, right? Because you need the same security rules for these 10 servers. Okay, so each server must have a firewall, must have a security group, but multiple servers can share the same security group. All right, you can filter. You can basically filter incoming traffic and outgoing traffic, but normally you're concerned with incoming. Right? Inbound traffic is what you want to control or prevent, right? And what happens in a security group is normally everything is denied, right? That's the default setting. Everything is denied, and then you can open up. You can say, okay, let's allow SSH traffic on port 22, right? Let's allow HTTP traffic on port 80, right? So you can allow certain things. By default, everything is disallowed. All right. Okay. So let's take a look at how to set this up. So basically, you'll have a security group. You can give it a name. For example, web server security group, a database server security group, application server security group. Right. So you can give it a reasonable, a relevant name, and then you have to sort of create your security group rules, right? And the rules are basically what do you want to allow, right? What do you want to allow? So in this case, for example, on this slide, you can see that we are trying to allow SSH, secure shell. Right? This is SSH is the protocol. It's a protocol that we use to connect to Linux instances. Right? For Windows instances, we use RDP. That's a separate protocol. Right? And the default port for SSH is port 22. Right? So that's why we say that's why we have to specify that. Right? We say port 22, and then we say source, right? Source is the source IP address. Who's allowed, right? Who's allowed on this port, on this protocol, right? And the source here, it says anywhere, right? And the IP address is 0000/0, right? The /0 is the network mask, okay? And 0000 is the IP address. And this basically means anything, any IP address, all right? It's not a real IP address. It signifies any IP address. So anybody, anywhere in the world, okay, can connect to your server on SSH on port 22. That's what this rule means. Okay. Now this rule, by the way, is a very bad idea. It's a very bad idea because on port 22, this is what system administrator will use to connect to the server and then do maintenance on the server, right? So you don't want anybody anywhere in the world to connect to your server on port 22. That's a very bad idea. Okay, so it's wrong. It's not. It should not be done. So instead, you should restrict the source. You should give the IP address of your corporate network, for example, right? Or your IP address, right? Just one IP address, a single host can connect to the server. So something like that. You should restrict the source IP address on port 22. That's very important. All right. Okay. Let's take a look at another example. You can set up multiple rules, right? You can set up multiple rules. So you can see here the second one talks about HTTP, right? So let's say this is a web server. You have a web application on this server. So what you want to do here is you want to allow HTTP traffic on port 80, right? From anywhere. Okay, from anywhere. So anybody anywhere in the world can connect to your server on port 80, right? And that is fine. That's fine because you may have a public website or a public web application. You want people anywhere in the world to connect to your application. So unrestricted access, right? 0000/0 for port 80 is fine. All right, but it's not fine for port 22. Okay, so this is how you should create your rules. You have to be very careful, right? Security group settings are very important on the cloud, because if you allow people to connect to your server, it's an open invitation for someone to attack your server, right? And it's only a matter of time, believe me, right? I've seen this a lot. I've seen people doing brute force attacks on my servers, right? You can watch them in the SSH logs, in the system logs, one request after the other. They're trying this password, they're trying that password, right? So it's only a matter of time before someone attacks your server, right? And sometimes they will get in, right? They will compromise your server. They may use it to send spam, for example, right? If you have valuable data, they may steal that. So it's a very serious thing, right? So you have to take care and make sure your security group rules are appropriately set up. Okay, so now in our demonstration, right, what do we do? Okay, what do we do? So what I'm going to do first of all is I'm going to create a server, a security group, and the first thing is to give it a good name. So let's say web server security group, right? So let's say this is my app. It's an app. It's a app that we have, and for this app we have a web server, and this is a security group for this web server or web servers. All right. And next, we'll set the rules, right? And this is basically the inbound rules. We're mainly concerned with inbound, right? Outbound is fine. If the server connects to the outside world on some port, that's fine. That's normally not an issue. We're mainly concerned. We are saying here the default rule says SSH port 22 and source is unrestricted, right? So anybody can connect to my server, which is totally wrong, right? So I'm going to change this. I'm going to change this, and I'm going to say my IP address, right? My IP address. This is the IP address of my computer at this time, right? This is my home computer, right? And this is not necessarily a static IP address. This may change. Okay, this IP address may change from time to time if the lease of my IP address expires, right? If I restart my home, the modem or the router, right? So the IP address may change, right? You have to remember that. But at this point, this is my IP address, and this is a better rule. Right? This is a better rule. Now you may be in a corporate network, so you should know your IP address or IP address range of your corporate network, right? And you should specify that here. Okay, so you can see the mask here is /32. Okay, this is the network mask, and /32 means a single host. Okay, so instead of a single host, you may have a bigger network. You may have a range of IP addresses that you want to allow, right? So you can set up your source IP address appropriately. All right. Okay, let's also add one more rule, right? And this is going to be HTTP. So let me find HTTP here, and this is port 80, right? Let's say we're going to set up a web application, WordPress on this server, right? So that's why we need port 80. And here we'll basically say anywhere, right? We'll basically say anywhere, which is unrestricted access. Anybody can connect, and that's fine. It's safer. It's safe to allow anybody to connect on port 80. It's not safe to allow anybody to connect on port 22. All right. Okay. Now let's proceed. Let's proceed. So this is the last step, right? There's actually one more step, but this is a review page. And let's just review, right? So what we're doing is we're launching an Ubuntu server. Okay, it's Ubuntu Linux. All right, and we have micro, which is what you should use because it's free tier. Then we have a security group, one rule for SSH, one rule for HTTP, right? This is for a web server, and so on and so on. Okay, but these are the three main things that we have for this server. All right. Now, when I click on launch, right? There's one more thing to be done, right? It says create or use an existing key pair. All right. So for now, I'm going to use an existing key pair, right? I'm going to use an existing key pair, and later in another demonstration, I'm going to show you how to create a new key pair. Right? Let's keep things simple for the moment. Let's use an existing key pair. I'll explain all this in due course. Okay. So I'm going to use an existing key pair. Now, first of all, what is this, right? What is a key pair? Let's try and understand that. All right. So a key pair, right? It's a pair, which means there's one private and one public key, right? So it's a pair of keys, right? And this is basically used in the Unix world, in the Linux world, to connect to a server, right? So to connect, each user, right, must have a private key. Okay, so it's like a key to your home, let's say, right, or your office. So you need to have a private key, and then you need to supply that when you connect to the server, right? And then your private key is matched with the public key, which is installed on the server. Okay, and once the two keys are matched, the server lets you in. Okay, lets you come in, and then you can run your server commands. Right. So this is broadly how it works, and this is nothing. It's not AWS specific. Right. These are standards. These have been in use for decades. Okay, in the Unix and the Linux world. Okay, it's a much better mechanism than passwords, right? Which is what we use on Windows, and this is much better than passwords, because passwords, people find it difficult to remember passwords, right? So they tend to keep simple passwords. Maybe your spouse's name, kid's name, 1234. Phrases like 1234, ABCD, birthdays, right? So people tend to include those in passwords, and therefore they are vulnerable, right? Passwords are vulnerable to attack. Also, passwords are stored on the server, right? And if someone gets into your server, they can steal those passwords, right? Remember, recently there was a case where Yahoo said that some years back, 1 billion accounts were compromised. Basically, the passwords were stolen, right? So that happens because in the password idea, the passwords are stored on the server. They are stored centrally. Therefore, they are vulnerable, right? They are vulnerable to attack. Okay. In this system, what happens is the private keys are not stored on the server at all, right? They're not on the server. They are decentralized. Okay. So you may have 100 servers on this, 100 users on the server. Each user will have his or her own private key, right? And the private key is only with the user, right? It's not on the server. So there's no way for someone to attack your private keys. Okay. Also, there's no way to derive the private key from the public key, right? So this is all math. Okay, this is all math. It's cryptography. It's math. These are beautiful algorithms, right? And so it's a much better system than passwords. Okay, and they're used in Unix and Linux, but they can also be used with Windows, like I'll show you. All right. Now you have to understand the difference between Windows and Linux, right? It's mainly a bit of history. Windows came from the PC world, right? Personal computing world. It was for end users, right? And the main thing with Windows is user friendliness, right? User convenience, user friendliness. So these things are probably, they thought it's too complicated, right? So passwords are better. So that's why in Windows you normally use passwords, right? But Unix and Linux came from the academic world in the US, right? All this is from the US, and in the academic world, users were mainly say computer science type of people, right? And they were more interested in the security aspects. So that's why these things are more used in the Unix and Linux side. Okay, so that's the little bit of history there. But there's no doubt that these are better. Okay, this is better. It's a better system for authentication than passwords. All right. Okay, so that's what the key pair is. Now let's see how to use this. So I'm going to use an existing key pair. So I have the private key already. Okay, I have the private key already. Later I'm going to show you how to create a new one, but I have a private key already. So I'm going to say, yes, I have this private key already. So just launch the instance, and then I'm going to connect to the server. Okay, so let's launch this server. All right. So okay, so basically the security group name is already in use. So let me just go back and change this. Okay, so let me just say 1 here. All right. Now let's launch this. Okay, so that's it, right? This is how you launch a server, right? And remember, we said cloud computing is on demand, right? On demand. So there's no waiting. There's no you're not requesting some person. There's no person sitting who's going to approve your request. Nothing like that, right? You want a server, you get the server right away. There's no intermediary, right? There's no IT department. There's no vendor here, right? And you don't have to wait. You get the server right away. Okay, so this server is coming up. and it takes just a few seconds, right? Usually it takes a few seconds to come up. You can see it's already up. It's in a running state. Okay, it's already in a running state, which means you can now connect to it and start using the server, right? You can start running some commands, installing some software, deploying your application, right? All those things you can do right away. All right. Okay. Now, next I'm going to show you how to connect. Okay, how do we connect to this EC2 instance? Let's try and understand that. So this server, if you look at the details panel in the bottom half of this screen, you'll notice IP addresses, right? So there's this one here. This is the public IP address of the server. All right, this is the public IP address of this server, and you can also see private IP. Private IP is something else. We'll talk about these things later. But at the moment, what we need is the public IP address. We use the public IP address to connect to the server. Okay, so I'm copying this. Let me copy this server, this IP address, and now I'm going to try and connect to the server. And to connect, I'm going to use the terminal program. Okay, this is a program on a Mac, right? On a MacBook. This program is also available normally on Linux machines. Okay, on Windows this is not available. But what you can do is you can use an SSH client called PuTTY, right? PuTTY. So normally people use that. It's a free software, PuTTY, right? There may be other SSH clients as well, but that's the most commonly used SSH client. All right, but you know, it's the same thing, right? Whether you're using a Windows computer or you're using Mac, right? Whether you're using terminal or PuTTY, the protocol is the same, right? The method of connecting is the same, right? You need the same input to be able to connect successfully. Okay, so let's take a look at how to connect using this terminal program, and then we'll also talk a bit about PuTTY a little later. Okay, so the way to connect to the server is to use the SSH command, and you say -i, and then you supply the private key. This is the private key. Okay, remember, private key is always with the user. The public key is installed on the server. All right, so this is the private key, and then you have a user called Ubuntu. Right? So when you launch an Ubuntu Army, when you use an Ubuntu Army to launch your server, there is a default operating system user created on the server. Okay. Now this user, the username is Ubuntu. Okay, that's why we're using this username here. Okay. Then we say @ and then the public IP address. All right. This is how you connect using SSH. So you need three things here: the private key, the default operating system username, which is Ubuntu in this case. Right. It may not be Ubuntu if you use a different army. All right. And we also need the public IP address. Right. So these three things are required to make an SSH connection. All right. So we say yes here, and that's it. This is your Ubuntu server. Okay. This is your Ubuntu server. Let me clear this and let me run some Linux commands. Right. So for example, who am I? Right. Who am I tells you what user you've logged in as, right? And the user is Ubuntu. You can say pwd, which is the print working directory. This gives you the folder in which you are currently there, right? So this is pwd. You can also do ls, which tells you what's in this folder. Right now there's nothing in this folder, okay, and so on. And then you can also run some commands, to install software. For example, let's say we want to install Apache web server, right? Let's say we want to do that. So you can use what is called a package manager, right? In Linux, we install software using a package manager. This package manager installs the software and all the dependencies of the software. Okay. Remember, in Linux is different from Windows, right? Linux is very modular. Okay. So you have a kernel, a basic, software. And then you can install whatever packages you want, right? And you also need to install dependencies, because one package may be dependent on other packages, right? So the whole thing, the whole installation process, all the dependencies with the right versions, all that is installed by what is called a package manager, right? This is nothing to do with AWS. This is Linux stuff, right? And so what we do here in Ubuntu is we use a package manager called apt-get, right? and then we can run a command something like this: install Apache 2. Apache is the web server, right? And Apache 2 is the name of the software package that we want to install. Okay, so we'll run this command. But before this command, you normally need to run the update command. Right? This basically goes and checks for the latest versions of the software that is available in online repositories, okay, maintained by the Ubuntu project, right? So it goes to the online repositories and checks for the latest updates, and updates what is called the package index. All right, so we normally run this update command first before we install the software. All right, so that's done. Okay, that's done, and now I'm going to install the Apache web server. So the command is apt-get. Sudo is used for assuming root privileges, right? So sudo is to get the permissions. So sudo apt-get install and Apache web server, right? That's how you install that, and that's it, right? That's it. It's very simple on Ubuntu, especially. It's very simple. So that's it. We're done. Okay, we're done. And now I'm going to exit the SSH session, right? And we're out, right? We're out. Now this is my computer. We're back on my computer. All right. Okay, that's how you connect to an EC2 instance, and that's how you can also run some commands and install some software. Okay. So now let's say one more thing, right? Let's look at one more thing before we open this up for Q&A. So now I'm going to test the Apache software, right? So what you can do is you can use the public IP address and paste it in your browser address bar, right? And if you do that, you should see the Apache default home page, right? Which means your web server is running successfully, right? And it's also responding, which means your firewall, your security group settings, all those things are working well, right? And here, so let me share this IP address with you. Okay, let me share this IP address with you. You can paste this IP address on the browser address bar and test out the Apache web server. Right? Okay. Okay. Now let me stop here. Let me stop here. I think we've seen quite a bit. Maybe it was a little bit fast, right? So let me know. Let me know. I think this is enough for today. And what I would like you to do after today's session is to try this, right? Launch your EC2 instance and try and connect to it as well. Tomorrow, I'm going to show you how to install an application, right? WordPress. We'll install MySQL. We'll install the WordPress application, and then we'll also point a domain name to the server and see it working end to end. Okay, that's coming up tomorrow. All right. Okay. So let's see. What questions you have. This is a very important step, by the way, right? So many people get stuck at the connection point, right? So they don't know how to connect, and that becomes a bit of a barrier. You can feel discouraged, right? So it's very important to cross this barrier, and therefore, let me know, right? If you have any concerns about this, please let me know. It's very important. All right. Okay. Okay, so Babita, how did you log in without PuTTY? So in a Mac we can use terminal. All right, a Mac or Linux we normally use the terminal program, which is it comes with the OS. Okay, it comes with the OS. On Windows, if you are using Windows, you can use PuTTY. All right, Chandra, is this public IP going to change if we restart the instance? Yes, yes. Okay, we'll discuss this tomorrow when we talk about IP addressing. But yes, it is going to change, and that's something that you need to be aware of. For something which is more permanent, that's why we use elastic IPs, right? So elastic IPs are more permanent. Well, not more permanent; they're just permanent. Okay, they're allocated to your account, and they are there. Okay, so if you don't want your IP address to change, you should use elastic IPs. We'll talk about it tomorrow. Okay. All right. Rao, unable to understand the demo key. We've not generated any key pair. Yes, I'll show that to you tomorrow. Okay. So tomorrow we will create a key pair. Okay, we'll create a key pair. Uh, uh, but you know, I just did this to make it simple. Okay, to make it simple, because when you create a new key pair, you need to sort of download the private key file, and then you need to secure it. So there's a bit of you know, there's a bit of there are some steps involved. All right, but we'll see it tomorrow. We'll discuss this in more detail tomorrow. So right now what I did is I used a key pair which I had created earlier and used earlier. Okay, so you can do that as well. Okay, Gajendra, elastic IP and static IP, are these two the same? You know, yes, you can say that. You can say that. Okay, you can say that they are static. Okay, elastic IP is static. You can say that. Yes. All right, but remember, this is the server IP, right? It's not your IP. Your IP is something different. The server IP is something different. All right, so but yes, elastic IP is a static IP. Okay, Shyam, what if private key on my machine gets deleted? Well, you cannot connect to your server. Okay, and nobody can help you. Okay, so that's how these things work. Okay, so key pairs work that way. Nobody can help you as well. So there's no point in, you know, you can't go to AWS and say, help me, right? A private key is lost. They can't help you. Okay, and this is not an AWS issue, right? This is how the SSH key pairs work. If you lose your private key, you cannot connect. There's no way to break it, right? Because, you know, if there was a backdoor, if there was some way of helping you, right, then the attacker would use that same backdoor, right? So there's no backdoor. There's no way you can connect to the machine if you lose the private key. All right. Now there are some ways in which you can get out of this problem, right? You can create an army from the server and then create a new server, okay, which will have a and at this time you can create a new key pair. Okay, so you can, you know, do things like this. But normally, you know, if you lose a key pair, normally, you know, you'll have a system administrator who has access to the server. They'll create a new key pair for you, right? Okay, so here let me not say nobody can help you, right? But let me say, so maybe a system admin has access to the server, right? And they can recreate a key pair for you, right? So something like this is possible. But if nobody else has access, to the server, right, then there is no way you can get into the server. Okay, this is required for, this is as designed, this is required, right? This is how it should be. All right, can you please point to the recordings? I missed a few minutes. You will find this on the LMS. Just log into the LMS, right? Just log into the LMS and find it under the module, right? So for example, module 1, just you'll find the recording under the module. And if you can't find this, write to support. Okay, write to support at edureka.co. Okay, because, you know, I'm just an instructor on this platform, right? So I don't deal with this. I don't know much about this. It's best that you write to support with requests like this. All right. Okay. Some more questions. So Babita, if I've created an instance using laptop 1 and want to work on laptop 2, do I just copy the PEM file and PPK file to a new laptop, or do I need to change anything? No, just copy. Just copy. Right? Just copy the PEM or PPK file. By the way, you know, for others, PPK file is what you create on a Windows machine, right? So you need to convert the PEM file to a PPK file before you initiate the SSH connection. So that's what the PPK file is. So just copy the PEM and PPK file or PPK file to laptop. Okay, that's fine. That's fine. It's your key. You can use it on all your devices. That's fine. Okay, now trying to understand the process. You generate a key pair and upload the public key to the server and use the private key to connect. Is that correct? Yes, yes. In general, right? In general, what you do is, look, first of all, right? The first time you connect, okay, a key pair, and if you create a key pair, then the public key is installed automatically for you on the server, okay, with a default user. Remember, the key pair is for each user, right? Each user must have their own key pair. So the first time you connect, you create a key pair. The public key is installed automatically for you under the default user, which is Ubuntu for Ubuntu servers. Okay, the default user is different for different servers. It is EC2 user for say Red Hat, all right, and so on. So under the default user, you get a public key already installed, all right, and then you download the private key at the time of launching the instance, right? So this is how it is done. So this is the default user. Okay, normally under normal circumstances, you need to do your user administration, right? Which means for each individual in your team, create a user account on the OS and install and create a key pair for each user and install the public key on the server for each user, right? So you need to do your user administration, the normal stuff that you do with non-cloud servers, right? Remember, all these are multi-user operating systems, right? So the default user, the Ubuntu user that we are seeing now, is just for the initial access, right? After that, you have to manage the server just like you would manage any other server, which means creating your users, deploying private, the key pairs for each user, right? So the normal user administration has to be done on these servers. That's very important. You should not share the default user. You should not share the private keys, right? So each user must have their own credentials. All right, Vivek, can we practice? Yeah, can we use Windows? Yeah, so but unfortunately I don't have Windows. Okay, so I don't have Windows. So I don't have a Windows machine. I don't have a Windows machine. I haven't had a Windows machine for many years. Okay, so unfortunately I can't help you there. But it's only the first step, right? Once you connect using PuTTY, everything else you can do. All right. So PuTTY is just one step, the initial connection, and once you connect, all the installation, all the other things that you're going to see is the same whether you're on Windows or not. All right. So the SSH connectivity is only one step, right? Only one step. It's not too important. Okay. All right. So hopefully it will not be a problem. Okay, any console like vSH, vSphere client for the server. I'm not sure what this is, right? I'm not sure what this is. Is it some kind of SSH client, right? Let me know. Let me skip this. You can expand on this question. I'll come back. Okay, Gajendra. Okay, it's called infinite storage. However, the data center region will have some limited capacity. Any reason it is called infinite? Yeah, it is seemingly infinite. This is a term that is used. Okay, it is seemingly infinite. For your purposes, right? From your perspective, it is infinite. Okay, because you can add, no matter how much you want to add, it's there. That much capacity is there, and they keep expanding. They keep adding capacity. Okay, in fact, in the past, for S3 especially, right? AWS used to run a counter, saying how many objects they have, how much the capacity is increasing, right? So they keep adding capacity, and they always have more than the projected requirement, right? So they're always ahead of projected requirements, because they know, how much the storage is growing, right? How fast it is growing. So they keep adding faster than the growth. Okay, so it's seemingly infinite. Yes, it is finite, in practical terms, but from a user perspective, it is there. All right. Okay, folks. So I think we're out of time, but let me just go ahead and finish this. All right. So let me just take some more minutes and finish this. Let me just answer these questions because maybe this will help you with your practice after today's session. Okay. So Sachi, if you deploy on this IP, if many users hit on this to overcome. Yeah, okay, basically you're talking about server capacity and what happens if there are too many users, right? So we have to launch many more armies and deploy the same things on it. No, we'll talk about this. Basically what you do is if you need more servers, okay, you create an army from this server, right, first, then use that army to launch more servers. Okay, then all these servers need to be behind a load balancer, as well, right? So all these things are coming up. We'll discuss all that. But in general, you don't have to reinstall, right? Because you normally create an army from this one server, right? For example, here, this is our server, let's say. So you simply go and say create an image. That's it, right? This will create an army, and then you can use that army to basically launch as many servers as you want. All right. Okay. Is there any folder where we need to maintain the private key? No. It can be anywhere on your machine. All right. So it can be anywhere on your machine. All right. Babita, if private key is lost, you can regenerate using the PEM key, and PEM key you can get from the server. No, you can never get the PEM key from the server. Okay. This is I'm just saying no in bold because I just want to be I want to emphasize that, right? So a PEM key is not stored on the server. Okay, in fact, it's up to you, right? See, normally when you create a user account, you have to generate a key pair and store the public key, right? You can store the private key, but that's a totally bad practice. All right, you should never store the private key on the server. Okay, never store private keys on the private keys for your users on the server. All right, and this is again nothing to do with AWS, right? This is Linux and Unix topics. Okay, it's not AWS specific. This is how things are done. You never store private keys on the server. Okay, Shyam, when working on as a team on AWS, do we have a common group login account so that all can have access to the apps on the instance? No. So it depends on what exactly you're doing, right? So never have common SSH user accounts, right? So you don't want to share SSH IDs, right? Because then something happens, you don't know who's done what. Okay, so for accountability, right, and for other reasons, it's very important to have individual user accounts for each user in your team. Okay, so basically what that means is when we connect, right? Let's say here I'm connecting using this user Ubuntu, right? But normally you will not be using this. Okay, you have to get rid of this account later. You have to have, say, you have one username called Shyam, another username called Babita, right? So you need to have individual user accounts, which means if Babita is signing in, there'll be Babita written here, right? If Shyam is signing in, Shyam will be written here. Okay, so each person must have their own operating system accounts, right? And that's the job of a Linux administrator, right? A Linux administrator has to create individual accounts for each person in your team. Okay, Shyam, what's the password for the default user created on the instance? Say for Ubuntu user, no password, because we are using SSH, right? SSH keys are like passwords. You can have passwords in addition to that. Okay, you can do that, but by default the server is not configured with a password. Okay, SSH keys are much better than passwords, so we don't need passwords. Okay, last two questions, right? Let's just finish this as well. So are we going to have a demo on key pair generation? You said yes, tomorrow. Okay, we'll do that tomorrow. Today I just wanted to keep things simple, right? We'll do this tomorrow. Okay, Babita, as a first step for SSH, we are asked to copy the PEM key in SSH.ssh folder. Then how come it's not accessible? No. So, are you talking about the private key, right? The private key. So the private key, right? The private key can go into your .ssh folder in your laptop. Okay, not on the server. Okay, so that's how it is. That's how you never store a private key on the server. Okay, the public key goes into a .ssh folder on the server. All right, that's true. That's true. So public key is installed on maybe in a .ssh folder. All these things are standard, but you don't need to do it this way. But you can do it. Normally, it is done this way. Public key is installed in a .ssh folder in the user's home directory, right, on the server, right? Not the private key. Not the private key. Yeah. PPK. Yes. PPK can be has to be generated from the PEM file, right? And we do that because PuTTY doesn't work. PuTTY doesn't work with PEM. Okay, that's the reason we generate PPK. It's just a format change, right? But that doesn't change the fact that the private key is not on the server. All right. Okay. Can you revisit row 32? Okay. So, but suppose it's a common project where the team is working upon. In that case, no, never. It's always a common project, right? So never. So no. So you can do it, right? Look, you can continue. You may have 10 people in your team, right? You can use the Ubuntu user, right? All 10 people can use the same user, same private key. It's fine, right? If you have trust in your team, you can do that. But as a best practice, right? As a security best practice, right? Security best practice is to have different user accounts and keys for each individual, right? And remember, it's not that hard, right? You don't have to worry about this. It's very, very simple. It's very, very simple. You don't have to worry about it. It's a one-time exercise, right? It's a one-time exercise. So don't worry about this. It is a one-time setup, right? Once you do it, and then you don't have to do it again. All right. Okay, folks. So now this question, do you mean does a team share a common AWS account? Yes, they share. AWS account is common. Okay, but AWS account has nothing to do with the EC2 operating system. Okay, we'll discuss this. Okay, we'll discuss this more. AWS account is a totally different thing from the SSH connections. All right. Okay. In the case of AWS as well, you need to have different user accounts for each individual. That we'll see in IAM, Identity and Access Management. Okay. All right, folks. I think we are 10 minutes past time. In general, let's stop here, right? So I think it's a good discussion. We'll continue tomorrow, right? We'll finish the EC2 module tomorrow, and tomorrow we're going to see more of the same, how to connect, right? I'm going to discuss PuTTY a bit more, and we'll also see how to install WordPress and see it working end to end. All right? Okay. So see you tomorrow. Have a good night. Bye.